Good morning, students. Today we'll be learning about pressure in liquids. As we have discussed earlier, liquid exerts pressure in the walls of the container, which is known as lateral pressure, and it is denoted by the letter P. P is equal to H into D into G, where H is the depth or height of the liquid, D is the density of the liquid, and small g is the acceleration due to gravity. We'll start with an activity. We are taking a glass tube, test tube, with both the ends open. One end of the tube is covered with a thin stretched rubber membrane and it is tightly tied with a string. The tube is held in vertical position. Water is poured into it in such a manner that half of the tube is filled with water. We are observing a bulge which is produced in the rubber membrane which is tied in one end of the test tube. Now we are increasing the level of water. The water is poured into the test tube so that 3/4 of the test tube is filled with water. Now we are observing that the bulge produced in the rubber membrane increases when the height of water in the test tube increases. You can see it in the diagram. We can conclude that lateral pressure increases with depth or height. Here the height of the liquid column increases, so lateral pressure is also more. It is putting more pressure into the rubber membrane and the bulging is more. There is one more activity which is telling us the dependence of lateral pressure on the density of the liquid. Now we are taking this time two similar test tubes, that means of same diameter and same height, and both the test tubes have two open ends. One of the ends are tied with stretched rubber membranes and it is tied tightly with string, and the test tubes are held in vertical position. In one test tube we are pouring water up to a certain height and the height is noted. In the second test tube we are pouring kerosene oil up to the same height as that of the liquid. Now it is observed that the bulge produced in the rubber membrane due to liquid pressure, this bulge is more in case of water than in case of kerosene. Why is it so? Because we know that lateral pressure P is equal to H into D into G, where D is the density of the liquid. Here height or H is are same in both the test tubes. Height of water and height of kerosene are same. So height is not contributing to pressure here. Here the distinguishing factor is the density of the liquid. As water has more density than kerosene oil, so lateral pressure of liquid is more in case of water, so bulging is more in water, as we can see in the diagram. There are certain applications of lateral pressure of liquid. The first one is, we can see that the walls of the dams are made very thick and it is thicker at the bottom. Why is it so? We can see in the diagram. Because liquid pressure, lateral pressure P is equal to HdG, where H is the depth of the liquid. So more is the depth, more will be the lateral pressure. So lateral pressure of liquid is directly proportional to depth of the liquid. So to withstand that huge pressure towards the bottom, the dam is made very thick at the bottom end. Similarly, one more application is the deep sea divers. They had to wear a specially designed suit to withstand the liquid pressure. Why do they do so? Because the divers, their body pressure, that means the blood pressure, it is accustomed to normal atmospheric pressure. It is balanced. Now, when they are suddenly moving to the deep sea region, if they don't use the specially designed suits, the lateral pressure of water increases due to depth, as P is directly proportional to H. So, the external pressure of water increases, but the internal body pressure remains the same. So, if they don't use a properly designed suit, the body will be crushed due to huge pressure of water. Why are the deep sea fishes die when they are taken above the surface of water? Normally, the body of the deep sea fishes, it is accustomed to the huge pressure of liquid at the bottom of sea. We know that liquid pressure P is equal to HdG. So, pressure P is directly proportional to the depth H. So, at deep sea region, pressure of liquid is quite huge, and the body of the fish is also accustomed and balanced with that pressure. When they are suddenly brought to the surface of the liquid, the internal body pressure is more than the external pressure, because when it is brought towards the surface or above the surface, the liquid pressure is also very low and the atmospheric pressure is also low. So, there is a tendency of the body of the fish to be burst. So, that is why they are not taken. Similarly, why are the hulls of submarines specially strengthened? Lateral pressure P is equal to HdG. So, the pressure increases with the depth of liquid. So, hulls of submarines are specially strengthened to withstand the huge pressure of water at the deep sea region. Now, we will be doing one more activity to prove that liquid exerts same pressure in all directions at a given depth. For this activity, the materials needed are a U-shaped glass tube, a wooden board, a plastic or rubber tube, a sellotape, a small funnel, a piece of rubber from balloon, and a strong cotton thread, and a bucket filled with water. What we are doing is, the U-shaped tube is mounted on a wooden board using sellotape. The wooden board is held in vertical position by some stand. Some colored water is poured into the U-tube such that the limbs are half filled with water, and it is to be noted that initially the level of water, colored water in both the limbs A and B are same. This setup is known as manometer. Now, the mouth of the funnel is covered with tightly stretched rubber from balloon. The stretched rubber is secured with strong cotton thread. One end of the rubber tube is connected to the stem of the funnel. The other end of the rubber tube is connected to the limb A of the manometer. So, rubber tube is making a connection between the limb A of manometer and the funnel. Now, the bucket is half filled with water and the funnel is lowered to the level PQ. It is observed that the level of water in limb B of manometer rises up and that in limb A falls down. Why is it so? Because whenever we are immersing the funnel into deeper region of water in the bucket, the liquid pressure increases. As we know, lateral pressure P is equal to HdG. So, P is directly proportional to depth or H. So, more is the depth, more will be pressure. So, more and more we are inserting the funnel inside the liquid pressure increases and it pushes the liquid column in limb A downwards, and automatically the liquid column in limb B will increase. Now, the difference in the levels of the limbs A and B that will give us the pressure of liquid at point PQ. This is a certain point PQ which is to be noted. Now the funnel, keeping it at the same level PQ, it is turned into different directions so that the rim is at level PQ all the times. It is seen that the pressure of water in manometer does not change. What does it mean? That keeping the funnel mouth at level of PQ, if we change the direction, then the height of liquid in limb A and limb B will remain unchanged. That shows that the pressure of liquid also remains unchanged at a particular level inside it. Liquid has one more property, that it seeks its own level. We are taking one apparatus which has 5 tubes of different shapes, and they are connected to each other by a horizontal pipe. The apparatus is fixed in vertical position and water is poured through any one of the vertical tubes. It is observed that the level of water rising to the same level in all the tubes, though we are pouring from only one tube. This fact is utilized in supplying water in a locality. A storage tank is made at a higher level than the buildings around it. The water flowing from the tank tries to seek its own level and hence it rises up through the pipes in each of the buildings. So, this is one more property of liquid we have learned. Now, we will be learning Pascal's law. It states that when pressure is applied to any part of the enclosed liquid, it is transmitted equally in all directions with undiminished force and acts at right angles to the surface of the vessel. It is shown in the diagram also. Here is one critical thinking question on lateral pressure. It is saying a body submerged in sea is brought up to the surface. Which of the following graphs represents correctly the variation of pressure on the body with decrease in the depth? So, a body was submerged in deep sea and it was brought to the surface. So, what happens to the depth? The depth increases or decreases, that you have to identify. So, from bottom to up it is coming, the depth is decreasing. Now, we know that lateral pressure of liquid is directly proportional to the depth. So, when the depth decreases, lateral pressure also decreases. Now, the graphs shows that depth of sea level in meter in x-axis and in y-axis they are plotting the liquid pressure. Out of the 4 graphs, you have to correctly identify the one which is showing the decrease of pressure with the decrease in depth. Thank you, children.